Hello guys, hello world, hello Philippines. Once again, this is I am a singer, eternal voice. So welcome once again. I'll be having my Tuesday uh, short duration live streaming. This is all about regarding basic formulas and equations that will be useful for all engineers. Meaning to say, this must be applied until you will practice in the real world of being engineers. So whatever engineering disciplines you are now, for example, electrical engineer, mechanical engineer, industrial engineer, chemical engineer, mechanical engineer, electronics, communication engineer. So the same thing. We should remember this basic formulas. So I'll be doing the presentation of basic formulas that we always used them since we are in elementary, high school, and college education. It will just be the same. There are only addition to make it complex and to give us further knowledge that we can solve certain problems in another mathematical approach, but it's just the same. So most of the engineers will use the shortcut equations or shortcut methods to deliver the correct answers rather than using the most complicated equations and formulas that will yield the same answers compared to those basic and not complicated formulas and equations. Okay, so this will be, shall we say, permanent since the times of our uh, oldest generations and until now, from the times of our, scientists, and now we still use that. And even up to now, our younger adapting to these basic formulas and equations. Okay, others may forget, especially if we are not working. Okay, but some also could easily remember. Okay, especially when we deal with numbers. Okay, especially most of the engineers will really memorize or will really retain in our brain cells regarding basic formulas and equations, particularly in mathematics and of course formulas equations in science or sciences, pure sciences, a lot, right? So it could be physics, chemistry, okay, and a lot more. Okay, so these sciences are very basic. The chemistry and the physics, and others will be just an additional. Okay, like that. Okay, now we're going to state to you. Actually, I don't vlog last how many days ago because I have so many uploaded videos that are not yet, approved by the YT administrator. And it took me a long time to, to monetize, really. And then in every video, you need to put description also. And sometimes also, it's very tasky to put the description, okay? Because other viewers cannot watch fully your videos. They are just reading the description of what you are talking about. That's how important the description because it describes the content of your vlogs, the content of your live stream, even though they will not watch at you or listen at you for a longer duration of time, something like that. So that's the relevance of having the description of each title of the video you uploaded in YouTube, especially if you are monetized, something like that. Okay, and there are a lot of restrictions also to follow. Okay, and then if you never follow that one, they will not approve, and they will not really approve you to be monetized. Even though your channel are monetized, but there are certain specific video that they will not allow you to be monetized, something like that. Okay, so it depends on the situations. Maybe in other cases, we can speak against the rules because there are sensitive also languages or gestures or topics that if you will be able to talk to that, then it will be a minus from them. So they will have the criteria to to sort out that video as not approved. Okay, something like that. And I have a lot not okay because my live streamings are not limited in in discussion. I can say what I say, something like that. Very opinionated, something like that. Aside from the content specific discussion, I have also to insert my own opinion like that, and then personal, experiences to connect with a present topic of the class that I'll be able to share with you guys. Something. Now I can come back, but before starting this basic formulas and equations, I would like to say happy birthday, Giancarlo Nepomuceno. Happy 16th birthday to you. Okay, like that. Now, we'll start now. So I promise that it's going to be a lengthy live stream. Okay, it's only a short period. Okay, so I want to get my código, but before that, as much as I could, I will I remember first the most basic equations and formulas. Okay, the first is you know, okay. So all basic formulas and equations will really fall, especially the quantities, the physical quantities, if it really falls to a scalar quantities, vector quantities, and tensor quantities. Okay, as an engineering student, or not only limited to engineering student, you can really identify so that it's easy for you to to derive formulas and equations like what is really a scalar quantity, vector quantities, and tensor quantities, something like that. Okay, okay. So okay, scalar quantities are those quantities that are not dependent to the direction. Okay, direction and orientation or the positioning where it goes, something like that. Okay, the vector quantities are dependent on the direction. Okay, from here to there, from point A to point B, from north to east, something like that. That's why, as you can notice, the speed and velocity have the same unit. Okay, meter per second or feet per second. Okay, like that. So you can remember that one also. Okay, like that. And both speed and velocity are rate, because there's time involved. Okay, as I am saying to you this over and over again, rate always deals with time dependent. Okay, so if we speak about speed, this is the rate of change of distance or the rate of change of displacement. So we can say that t delta change, small letter t, delta change over delta t. Okay, so let me just say rate of change of the speed. Okay, like that. So always remember that one, okay? Because it matters a lot in your computation. Okay? So going back to pressure, we first say pressure, right? Fluid pressure. Okay. So what is a pressure? Anybody? Pressure in our daily life. pressure is the force exerted perpendicular to the unit surface area. Okay, or simply stated as it is a force applied of an object. Direct definition. Okay, so is pressure is a scalar or a vector? Now that's my question. Okay, it's a scalar or a vector? Okay, pressure is a scalar quantity. Okay, most of the scalar quantity, guys, are having the constant value. Okay, having the constant value. For example, pressure 0 degrees Celsius. No, 1 atmosphere. Like that's a standard. There must be a value for the standards. But for the vector quantities, there's no such standard. Okay, if there is a value, then with respect to that certain specific quantities, for example, 32 meter per second at equivalent temperature, equivalent pressure, equivalent example only equivalent time. Okay, but there's no standard velocity of water written in the book. Okay, and then if there is a standard, and that is a scalar quantity like density, okay, temperature, pressure, concentration. These are scalar quantities because there are standards written in the book at a certain specific, parameters. For example, the density of water is 1 gram per ml at 4 degrees Celsius. Now, if you compute for problem solving, like involve the flow of water, then even though the problem will not specify the temperature, as long as you have water, it is understood to be 1 grams per ml. Sorry, 1 gram per ml, 1 gram per ml, and 1,000 kilogram per cubic meter. That means at 4 degrees Celsius. So that's our reference. But it's not stated in the problem. Okay? So it's automatically they will say the water will flow like this compute. But then the formulas require density. Then why we put 1,000 kilogram per cubic meter as our density? Okay, it's not mentioned. That is standard already. Okay, and then some also, not all, okay, some also doesn't know that the standard of density of water that is specifically at 4 degrees Celsius. Okay, malum. Okay, again, the standard temperature in which we obtain 1 gram per ml and 1,000 kilogram per cubic meter is at 4 degrees Celsius. Okay, the basis, something like that. Okay, even though the problems will not specify at 4 degrees Celsius, automatic, it will be used, that density. Okay, because that is water or pure substance. You can memorize that one also if you want. Just memorize common fluids or liquids at 4 degrees Celsius. So that is the standard also. For example, alcohol flow in the pipeline, blah, 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 so and so. What is the velocity and momentum going in the outside portion? Yan, ganun. And then it's not specified the temperature, pressure. So we will use also the density of alcohol at 4 degrees Celsius. Ganon. Okay, because 4 degrees Celsius is our standard. Okay, and then if you don't want, make water as your reference also. Okay, if you have the density of water at 4 degrees Celsius. Okay, and then you get the specific gravity, then bingo, you can get the density of alcohol. Okay, like that. So if you have a specific gravity, because specific gravity of a substance is equals to the density of a substance over density of water. So that is at 4 degrees Celsius man siya. Okay, so it could be automatic also that the alcohol is at 4 degrees Celsius also. Because normally, if it is a flow of fluid, both the same are going inside in one pipeline. So they are both having the same temperature, right? If you mix the alcohol and water, okay, what will happen? They share the temperature with each other, okay, because they are now one fluid and one liquid, okay, even though they are already a mixture, okay. So that's why it's okay also to get directly at 4 degrees Celsius the density of alcohol, or if you want, get the specific gravity of alcohol, okay, because you have already the density of water, the ganun siya. Okay, since you substitute the density of water at 4 degrees Celsius, so it's really understood that all of these alcohol and water are at 4 degrees Celsius, right? Okay, something like that. Because you cannot insert particular, numbers if you don't have the same quantity also. Okay, going back to fluid pressure tayo ha. Fluid pressure. So, pressure lang tayo magsugod because pressure have so many formulas involved and this will be used really, okay? Like that. So, pressure. Oh my God, I have no uh, pencil pen anymore. How can I do this? Fluid pressure and gas pressure. Okay. Oh my gosh. Wait for a while, ha? Pressure. Oh, ito na. Pressure is equals to force over area. Okay. Okay. Pressure is equals to force over area. This is equation 1. Okay. So in this alone, you can compute the value of force and also the value of area. Okay, so it is understood to get these quantities during cross multiplying with each other. Okay, so you will obtain pressure times area is equals to force. Ganon. And then if you want also to solve for area of force divided by pressure. Tama ba? Yes. Through this equation, you can obtain 3 maximum of formulas because there are 3 quantities involved also. Okay, like that. So in here, pressure is a scalar quantity. Okay, like that. Force is a vector quantity. Okay, and area is a scalar quantity. Okay, because there's no standard area. Okay, given, for example, what is the area of this? So it is variable. For example, this table, this laptop, it's variable because there's a lot of variants or models for that laptop and table. You cannot see particular one standard as a reference of their sizes and dimensions like that. So those are vector quantity. Okay, vector quantities. Okay, like that. So number 2. So pressure, another formula of pressure is dealing with height at a certain elevation. For example, above atmospheric level, ganun siya. Okay, so we have the other formula of pressure also. Okay, wait. Oh my gosh. 2. Nahulot na dyan akong ink. Sorry. Okay. So pressure, okay, density times height. This one. Pressure density of height. This is in the case that you are giving only the height and you can compute for the pressure, especially if water acts on it. Because water at standard is always 1,000 kilogram per cubic meter density. Or shall we say 1 grams per ml or 1 grams per cc, cubic centimeter. Okay, it's just the same values. Okay, like that. Density is the rho, like this. Okay, and h is the height. Okay, H is the height, okay, from the ground to the upper level. So this one is not applicable to the horizontal distance because in the first place, horizontal distance or horizontal axis is not a height. Okay, so you will be wrong if you substitute that value because that is also distance. But that is horizontal distance. That is a vertical distance, but not horizontal distance. But if you substitute the horizontal distance in here, you will yield the same unit, which is a unit for pressure. Be careful also. For example, at times when there is no height involved, and then the problem let you think what is really the vertical height, push you to analyze so that you can obtain the height because sometimes it will not be mentioned. Okay, so do not, and then the horizontal distance is given, so you will be tricked out and you will be able to substitute that h here. But that is not the height, okay? Even though the same unit and yield the same unit of the pressure. Okay, let's prove it why it will become a pressure. Density, let's say lang ha, density of water. Okay, 1,000 kilogram. Okay, per cubic meter. Okay, times height, which is 2 meter square meter. Meter lang siya, kay height naman siya. Yung area ha. Okay, ganun siya. Okay. So ang mabili na yun i-cancel ang meter. So this is kilogram per square meter. Okay, let's say 2,000 kilogram. Okay, square meter. This one, kilogram per square meter. 200 kilogram per square meter is already a pressure. Okay, but since the pressure unit is in Newton per square meter, then you can convert that also to Newton per square meter. Okay, but what I am telling that force can be treated equal to mass here if you don't consider the gravity. Okay, but if you try to consider the gravity, it will be another thing. You will be introducing another formula for the force. Just like this, okay? Because you want this to become ano siya, Newton per square meter siya para may mo siyang pressure. Actually, this is already a pressure. Okay. Pressure is assuming to have no gravitational force involved. Another story. The pressure is Newton per square meter. So that's why we need to, because Newton is a force, it is still kilogram at that. What I'm telling only that it is already a pressure, but there is PSI, okay, 200. Di ba ningon ko, force is equals to mass times acceleration, and that's G, wherein G bar, gravitational force, gravity down. This is 1,000 kilogram per second square is a Newton siya. So, pero ang unit is weight Newton day siya. Okay? Ini ang 1 meter.